Okay, good morning and a warm welcome from my side. I'm pleased to see so many participants to our webinar on the topic of deep learning. My colleagues, Rini Klausriger, Market Product Manager for Identification and Measuring, and Matti Nuic,
Hi.
Market Product Specialist, Industrial Vision and Systems, will guide you through the topic. If you have questions, just unmute yourself and ask them, or you can also type them into the chat. I will monitor that. And as soon as a question pops up, we will answer that. On a small note, the webinar will be recorded. You will receive your access to the recording as well as the presentation documents tomorrow per email. And on that note, with further ado, I will turn now the floor over to my colleagues. Have a nice day.
Hello. Thanks, Isabella. So let's start with our webinar. How deep learning makes your solution smarter. That's the topic for today. And as Isa said, next to me is Mate, our vision specialist, and he will support me. Good. This was already mentioned. The webinar will be recorded. But what are the agenda for today? We'll start with what does it mean with deep learning, especially in the field of machine vision. Then we take a look on which neural networks exist. Then the process of a deep learning project, how is it built up? Of course, we also show you what SIG can offer based on the products. And then a really interesting topic, realized projects. So we have realized projects from different industries like wood industry, electronic industry, food and beverage, metal and steel, but this we will see later on. Feature and benefits, this is just to summarize. And then we will start with the live demo. Live demo would be done for the neural networks based on classification and anomaly detection. And as mentioned by Isa, if you have any questions, so please unmute, jump in, and let's discuss about. Good, what it's meant by deep learning in the field of machine vision. If we take a look here on the left side, so what's our motivation? On the left side, you see our motivation based on the product, and on the right side, based on the usability. So we want to have 6 sensors for more complex tasks. For example, to sort and classify even naturally grown products. So everybody of you knows naturally grown products, you have a huge deviation variety within these kind of products to recognize deviations on complex objects and execute difficult assembly checks. On the right side, usability-wise, we're providing examples instead of rules. What's the difference between, we will see later on one of the slides. And user can solve applications themselves. This is pretty important. So to start with a deep learning project, I would say you do not have to, need deep machine vision skills or programming skills. So on the one hand, we want to increase the complexity, what our solutions can handle. And on the other hand, we want to reduce the complexity of the solution development. As I said, as easy as possible. Yes, and what we are doing here, we are combining endurance and reliability of a machine combined with the human perception. I always like it to compare deep learning by teaching a child. So if you want to teach a child, you want to teach him, that's a horse and that's a dog. So when you learn, we want to teach them, then you show them photos. And if there is a misinterpretation from the child and you show him a dog and you said, that's a horse, then show him more often a horse and a dog until it's clear for them. So, and this is more or less what we're also doing with deep learning. We are just teaching pictures, show them, calculate a neural network and deploy it on the device. If somebody of you already have dealt with machine vision, then most of you maybe know rule-based machine vision. And if we are speaking about deep learning, then we are speaking about example-based machine vision. So what means rule-based machine vision? Typical object characteristics of that are well-defined, predictable, and non-complex defects. So you have well-defined conditions, not that changing within some classes. So at the end of the day, we are speaking about well-specified objects. So typical application examples are quality inspections, or barcode reading is also a part of that. Measurements, when you're doing some measurements, you want to measure the volume or anything, and object position detection. So clear object specifications and tolerances. We take a look on the right side, example-based machine vision. So here we have complex and unpredictable defects. So like in tire production or soldering, which we will see later on an actual application, what we have sold at the headquarter at SICK. Or especially natural grown products like food or wood, because wood is not wood and food is not food. You have a huge deviation between. So also for deformable objects, so in the packaging industry, so you have deformed objects, and this also can be handled via deep learning. Typically, applications are classifications with neutral variances, and also quality inspections objects with unpredictable defects. So applications always built on good and bad or classes of objects. Yes, as a practical example, I like this example pretty much because the same example, I think, I don't know, 6 or 7 years ago, we had a similar application on the table, but at that time, we as SICK offered at that time not a deep learning solution. And because if you take a look here, what's the task? The task is here to distinguish between two pellets, an APAL pellet and a neural pellet. So this is an easy decision for a human, but how can it be automated? That's the question. So 6 or 7 years ago, we also started to, now it's working, started to solve this application with standard machine vision tools. So maybe some of you already worked with machine vision, and so you have this typical machine vision tools like pattern match. Yeah, of course, we can teach in the pattern, but as you can see here, so where is the mouse? But as you can see here, also this pattern, there's a big variation. So you can also, with the pattern match, you can set a score that the pattern have to be not to be matched with 100%. But at the end of the day, this will not working in that application. Or also an object locator or pixel counter. These are nice tools, but are definitely not suitable to solve, for example, this application to distinguish between the two Euro pellets. And this now, until now, we have solved this successfully with deep learning. So this was the introduction, and now we are taking a look on which neutral network exists. So because we have different neural networks, and depending on the application, you have to choose the right one. What we are as SICK take a focus on at the moment is the neural network for classification and anomaly detection. So object detection and semantic segmentation, here we are still working on, but we have no ready product at the moment, but this will be launched, I would say, in the course of next year. But let's start with the classification here. So what means classification? We are classify an object or a singulated object within one image. So if the object is present and which classes they have. So for example, sorting and singulated objects for assembly verification, for example, for okay or not okay decisions, or defect classification, what type of defect is present. So, and if we take a look on the availability of the images, so that means with this neural network, we have to teach all classes. What that means, we have to take an image from each class and upload this to calculate the neutral network. How this is going on, we will see later on in the when I explain you the process. So this is the classification. And when we go to anomaly detection, so anomaly detection means more or less you also take a look on an object within an image, but more or less you teach a golden part. And if something differs from this golden part, then you will get the information. So does the image contains any anomalies. It's especially suitable for surface detection. But here, if we take a look on the images, because we are just teaching a golden part, so that means in that case, we are only teaching good images, but we also can teach bad images to improve the neural network to be more robust. So we have both possibilities here. So, and then if we take a look on the object detection, here we are searching for one or multiple objects in one region. So what object is located within a certain bounding box? That means we can create a bounding box or more bounding boxes within one image. So this is typically for heating stations and also assembly verification. And also here, if we take a look on the images, we also have to upload all the images from all classes. And the segmentation is more or less the same than the object detection. Also, we are locating one or more object within one image, but here we can define a pixel region. So we can go really in detail. So, and we can define more pixel regions within one image. There's also same applications, kitting stations, assembly verification. And also here we have to upload the photos from each class. Okay? But what we want to show today and also in our live demo is one live demo for classification and one live demo for anomaly detection. Why we as SIG started with these two neural networks, because most of the applications are based on classification or anomaly detection. That is the reason why we started to take a focus on those neural networks. Yes, how the process of a deep learning project. So how you start with a deep learning project. So of course, at first we need a use case, yeah, and this use case should be clear to human beings. So it can be maybe difficult for classic machine vision. So maybe also it could be a good approach to start deep learning if you are still using a machine vision camera and you're working with standard machine vision tool and you have some problems. You do not have that robust result. Maybe this could be a solution to solve this application with deep learning. Then, of course, we need a deep learning enabled device. We need a deep learning app. And we need a neural network to train the neural network individually based on the application. On the next slide, we will see the steps. At first, you will start here to collect the images. So what does it mean? You're going, of course, to collect images. You need a SIG app-based device, yeah, and you need this. You take the SIG device, go on site, go in your production, install a trigger, and collect all the images. Collect for different classes, yeah, or anomaly. Depends on which neural network you will work on. Yeah. So, and if this is done, if you have collected the images, then the images would be uploaded because you have to label it. Because if you're capturing images, then somebody has to let the system know this is product A, this is product B, this is product C. So I would say the most effort or the biggest effort within a deep learning project is to label the images you have captured. Because you can imagine we have sometimes, I will show you later on, sometimes we have applications where we upload hundreds or thousands of photos. And of course, then somebody have to take care on that these are correctly labeled. And this is, as I said, the biggest effort within the deep learning project. After the labeling is done, then you have to upload the photos, for example, into the cloud, into our DStudio, which is a cloud service which we are offering, or we also can do this training directly on the device. This depends on if you're working with classification or anomaly detection. And after you have trained the neural network, then you have to evaluate. So that means you have to take a look on if the result of the neural network is good enough for you or not. If not, then you have to go back to capture more images and label them, train them and go again into the evaluation. But this we will see all of them afterwards. And if this is done, then you execute the neutral network to the device. So because what you are executing to the device is just a mathematic model, yeah, which is running directly on the device without any controller. So not the photos you captured are on the device. So, but here it's pointed out that DStudio, this is our cloud service. When we have, for example, classification task where we have to upload hundreds or thousands of photos, because this is not possible to do it directly on the device. And we also have the same possibility to collect images, to label them, to train them and evaluate them directly on the device. This is for projects where you do not have to upload that much photos, because we have restricted memory store on our devices, of course. Yeah, but this we also will see later on. So shortly summarize: collect the images, label the data, train it, evaluate it, and execute it. And all these steps, as I mentioned before at the beginning, do not require deep know-how in programming or machine vision. This is more or less a really easy task, much easier than standard machine vision tools. Now we take a look on our portfolio. So we will start here in the left corner. We're starting with the Inspector P611. It's this version goes up to 1.2 megapixel with pre-mounted optics and illumination. But illumination, you can change color and the shape of them. And it's the smallest size on the market at the moment. So at the moment, the Inspector 611 is the smallest sensor, which is able for deep learning as an embedded version, which means it's running directly on the device without any controller. Then you go ahead with the Inspector P620 series. So this goes up to 1.3 megapixels, also monochrome based. Also here we have pre-mounted optics and illumination, but we can change, of course, we have different order numbers with different lens types. And here on that device, we also have an electric photos during the auto setup. And this device we're also using for our live demo. What I have forgot to say, also the Inspector P611, we will launch in, I would say, 1 or 2 months with liquid lens. So that means here you have autofocus functionality on board. Then we'll go ahead with our Inspector P63 series. So as you can see here, goes up to 2 megapixels. And here we are much more flexible based on optics and lightnings. Yeah, so we can change lenses, you can change the lighting, the color, blue, white, red, or whatever, and also can use S or C mount lenses. Then our Inspector P64X and Inspector P65X. So here we go at maximum up to 4.2 megapixels. This also exists as a dynamic focus version. And here we are working on the new generation. It's called Inspector P8. And this goes up to 12 megapixel as an embedded version, which we will launch in the middle of next year. And here on top, we have more or less when you have to realize multi-head solutions. So we have the SIM, which is called SIG integration machine. It's more or less an industrial controller combined with 2D streaming cameras, which goes up to 12 megapixels. And this exists also as monochrome and also as color version. So if you want to realize deep learning based on color, then you have to take this combination. Also here, we are working on the project at the moment, and Mate and me will show you later on. So, and here in the right corner, you see SIG App Space. What does it mean, SIG App Space? So I like it always to compare it with a smartphone. If you buy a smartphone, then you have installed some standard apps. And that's the same what you have at SIG. So if you buy one of these inspectors, then you have already pre-installed the app called Quality Inspection, which offers you standard machine vision tools. And this app is free of charge. If this is not sufficient, I would say, so you are missing some tools, then you can buy the license for intelligence inspection, which offers you deep learning for anomaly and classification tasks. And if this is also not sufficient, then you can take our SIG App Space environment, and the SIG AppSpace environment is a programming environment where you can customize your own solution. This is also license-based, and you also see we are not only can work with our SIG library. Here you can also work with Halcon directly on the device. Just to take a look on. Okay, just good in time. Yeah. Any questions so far? So now we have spoken about, I would say, some basics, and if there are no questions so far, then I will go ahead. We realize the project. So
there are no
questions at the moment.
But, no,
yeah.
But just das Meeting vom MPM wird angezeigt.
Yeah. Okay. Sorry, I have to. Sorry. Yeah.
Yes.
So now we can go. Thanks, Isa.
No problem.
Good. Now, this is from food and beverage, so an assembly check. So what is required here? Here you have to check, because sometimes it happens that the operators put in wrong products or he missed to put it in. So in that case, there is a risk of the return of the entire delivery LKW truck. What does it mean at the end of the day? That does it mean you have additional costs, and this we want to avoid. So if we start here, these are 4 working stations we equipped with our new Inspector P611. And as you can see here, yeah, this could be not always in same position. So we also have always the conditions based on reflection are always not homogeneous. So, and also here on the second working stations, they put a second part here. This here you can have an overlay. And on the third station, they add some, it's like a spoon, yeah. And as you can see, the most challenge here are the reflections, yeah. So to handle this with standard, and maybe here you have also different situations between your morning shift and the night shift, for example, yeah. And in the 4th step, they add also like a can here. You see the can also can be in different orientations. So to handle this with deep learning, that's really a nice approach, and will run with high performance at the end of the day. This is something from metal and steel. So here, this is also a classification task to inspect a ring on the gear system. So here we have to edit 3 classes. So all bolts are inserted, some bolts are missing, or old bolts are missing. So if you take a look here for each class, for this class, we have uploaded 172 images. For that class, 337. So a lot of images. And as I mentioned before, somebody have to label this. Somebody have to let them know this is class 1, class 2, class 3. Yeah, and also here, the gear is not always on same position here. And maybe also the surface from the gear differs a little bit. And this makes it, or this is the huge challenge here to solve this. It's also realized. This project was done by our colleagues in Sweden, so in the wood industry. So what's the problem here? Here we have to check if the earrings are up or down. Yeah. So why? Because before they glue before they glue these together, these wooden beams, they have to check this, that the end product is more or less stable. Yeah. And the problems what we had here also is in the process before, this wooden beam would be cut it with a saw. Yes. And through the saw blade, you also have some scratches here, which looks like a earring, but these are just scratches, yeah, and these have to be recognized by the camera. And also, this is a typical example for natural chrome product, because you have different variations of early wood and late wood. You have different kind of wood, and so on and so on. And so it's fantastic here, as you can see, to solve this application, to have an accuracy around 98 to 99%. We uploaded 160,000 images. And again, somebody have to label them. Yeah? And in this kind of, here you will see the evaluation, but this I will explain you in detail more when we go into the live session. Maybe within this application to reach 100% is maybe not possible. Of course, you can load additional 20,000 photos to reach close to 100%, but to reach the 100% would be really hard in this application. This is a project we have realized at our headquarters in the AG in the Black Forest. So this is a solder joint inspection. So what's the task here? We have the solder process on the left and then the handling process. And this here you can see the soldering. And what we have to check here on the PCB board if all the soldering was done in a good way. So there is also a video. So here you can see Inspector P. The robot grips the PCB board, shows to the camera in different angles, and then it will be checked. So on the left here, these are all are good. And on the right side, that's bad here, no time. Here we have no connection. And here we have a short circuit. So to solve this with standard machine vision, and when you take a look here on the OKs, also the OKs differs really huge from each other. This is more or less, as you can see here in these pictures. And yeah, but it's running still in our team production. The team is our 2D LiDAR sensor, and it's running, I think, since close to 1 year successfully within our own production. This is the project I showed you at the beginning of what we have realized to classify the pellets. So on the right picture here, you see Mats Götztorp. It's the chairman of our board. And as you can see, he's pretty happy about the award. And yeah, this is more or less the task which I have explained to you at the beginning to classify the Euro pellets and also other pellets. Nice project from where we are still working on. So it's done by our distributor from Greece. So also nice approach here. We have to classify olives. So olives are already packaged in it's like a plastic tray, yeah. And you have to classify which kind of olive are present. So I think to distinguish between variant 1 and variant 4, it's not that huge. It's not that difficult, but to distinguish between variant 1 and 2, this looks more or less similar. That would be a hard task. Yeah. What is the approach here? Here, our colleagues from Greece used a controller with a streaming 2D cam because we want to solve this application with color because this helps us. Here you can see how they built up the test with a huge dome to have homogeneous lighting conditions. And here you can see, yes, that's the product more or less. And we trained the neural network with 100 images per class and had an accuracy in the in-house test around 100%. So as you can see here in the right corner, also on the evaluation, no mistakes are, no misinterpretations are here. So also a nice project. Just we have tested in-house, and now we will go in the next step to test it directly on site. Good. And the last application also from food and beverage, this was done by our colleagues from Switzerland. So what's the task? So incoming boxes with bananas are depalletized automatically. And for each box, a decision needs to be made if the bananas are green, almost green, yellow, or overripe. Yeah. So, but the challenge here, we are speaking about a natural grown product in combination with poor visibility and variable setup due to packaging in card box and plastic. So as you can see here, there is just the chance to see within a little field of view the bananas. All other is covered by the board. So what have they done? So these are some example images, as you can see here. Maybe in this one, you just see foil, not really a lot of bananas. And they did a nice approach. What they have done, they have splitted the images into single tiles. So that means they take a look on and define following classes: cardboard, plastics, yellow, green, and black. And if the tile is showing mainly cardboard or plastic, then this is ignored by the system. So if you take a look here on the right, it's hard to see, but these are, here is just carton box. This is more or less ignored. And if you take a look here, this is yellow. Here we see the bananas. This element would be taken to evaluate. And also here, it's still a lot of plastic, but it still sees the bananas here. So they split it into single tiles, and this was at the end of the day the success of this application. Good. So now we are ready with the, and just shortly summarized. So the features, so also the interference is executed directly on the device. So that which means we don't need external controllers, so you can do the evaluation directly on the device, but we have both possibilities also with the controller. We are of an online training with DStudio or directly on the device. I also mentioned that. So, but here we will take a look online later on. Deep learning is a part of the AppSpace ecosystem. So that means it's a part of our programming environment of our, and also next to deep learning, you also can use the standard vision tools, which are offered, for example, quality inspection. And we have our neutral networks are optimized for SIG devices. So that means the neutral networks also programmed by our SIG developers. We are offering trial versions and individual assistance via support portal. So if you have a license, then you also will be supported by our support portal by our specialists. Yes, to summarize it short, what's the key message with deep learning from SIG? You can solve more complex machine vision applications with less effort. You can retrofit existing applications with deep learning to improve reliability or detection rates. You reduce cost for your machine vision system. You can make fast and simple visibility checks without upfront costs. Your application is extremely customization-able with SIG AppSpace, and you can configure your solution with the Intelligence Inspection app. Good, and what we are offering based on service, so I have to hurry up a little bit now. Yes, starter package gold, which means we are coming on site and teach you as long so that you are expert in deep learning. We are offering this free online visibility study or trial license. This I will show you live. And we are also offering classroom training. So we have a compact learning set here with complete learning material. So if you're interested in that, so please let us know. And now we're going to the live demo. So what is our first live demo? The first live demo is the classification of buttons. So buttons should be classified into 5 classes. Buttons not always placed in the same position or orientation, and we have reflective material. So the first class is okay. Then the second class should be scratched, then bent. As you can see, to distinguish between bent and okay, that's pretty difficult, or no nail, or wrong orientation. And the second live demo which we'll show you is based on this SD card. Here will Matej show you how to build up from scratch the application. So here we have to detect anomalies on the connectors of the SD card. What we have done here on the left, we have a good one and then not okay. So this is really just slightly scratched. It's also really difficult to see it with the human eyes. And here we have bigger failures here, not okay. We also have scratched here and painted something a little bit. And on the right one, we added some solder on it. Yeah. So, but now I want to show you. Now I go directly into the DStudio. So this is the DStudio, our cloud service, and you also can have access to that. You just have to register on your homepage and then click on DStudio. So I launch a project, but this project, of course, I already did the capturing of the images. So this is the project button 5. Yeah. So as you can see here, for the bent, I have uploaded 245 photos, then 244 from OK buttons, then no material, of course, just 10 photos because this is pretty clear, or also no nail. We just have uploaded 50 photos because this is more or less clear for the system, for the neutral network. and also the scratch ones. I uploaded more than 200, and wrong orientation also just 50 images, because this is more or less easy for the neural network to identify. Yeah. So, and I have uploaded them and labeled them. So, and the next step is to create the project. This I also already have done. So I did already the training. Yeah. And this you will see here. Sorry. That's the training, what we have done. And the training here took 58 minutes. And here you can see we have more than 24,000 training steps. And as you can see here, the red line is the training and the blue line, the evaluation. And we never reached 100%. And this we also will see in reality, that we have some troubles with this neutral network. But I think this is a good example to show to you. And then we are doing the evaluation. So you can take a look on the DStudio if your application is working in a nice way. Because as you can see here, we have some misinterpretation. On this X, you find the ground truth, and on that X, you find the prediction. So as you can see here, band, sometimes there always is a misinterpretation. It's banned, but they say also it's an OK button. And also in the class of button OK, as you can see here, 38 are classified correctly, but some of them are also classified as banned. So we have some misinterpretation here. And maybe, and also I want information. So if you upload 100 photos, I think 80 photos, Mate, or are used for the training, to train. How many?
Sorry, 80% is used for the training, and the remaining 20% are used for this evaluation task. So means in the training process, I tell the networks, okay, this is this class and this is the image to this class. Then afterwards, in the evaluation part, I'm just telling the camera, okay, here you got now an image, and tell me which class it is. So it's now it needs to make it by itself to say, okay, which class is it now, and then later on this evaluation task is generated by this data.
Okay, and if this is done, yeah, and here you have the evaluation, and if you're not successful here, then you can go back. But if the evaluation is okay for you, then you can go to the deployment, yeah, and I can download this mathematical model to run it directly on the device. And as I said, what I have done here to upload the photos to evaluate the training is done without any cost. So also you can do that without any paying. And at the end of the day, you can download this trial model. And as you can see here, it's written after 120 minutes, then you have to reboot the device again. And then you can work again 120 minutes. So this helps you to test if this neutral network is working in your application. And if it is fine for you and you have good performance, then you can buy the official license for this mathematic model. Good. So I'm ready so far. So I will hand over to Mate, because Mate will show us. So please share a screen. I quit here.
So
we also will.
I think you need to mute yourself, René.
Sorry.
So I will also turn on the camera and now change it. So I hope everyone sees our camera. Yep. So, and I'll start with sharing my screen. So we already prepared here. We got an app called Classification Learner, where it's very easy to just see, okay, how is my app running or my network running, and to see as well also, okay, especially for these two classes, which we said, okay, they are a little bit problematical maybe, to say, okay, what was the interpretation of the other ones. So now we can make an image. As you see here, no material. So now René will put a scratched one on the table. As you can see, as well scratched. We can also maybe try, which also can do it. We can also maybe change the exposure time, still interpreting it as scratched, although there is really not, the scratch is not really good visible. We could also go in the other direction maybe. Yeah. And maybe just to show the two classes which are problematic, to distinguish. So here, this one is banned and will now be classified. Okay, now it's classified as banned. So now we maybe move it a little bit. Still 100%. Okay, now it's working very good. But the thing is, it can sometimes happen that, as you can see here, it's now 88%. It says it's okay, and 10% it thinks it's scratched. So
maybe just one, I can show you here. So this is the normal one, and this is the bent one. Yeah, and this is pretty hard to see if you take a look from top to distinguish between them. Yeah.
yeah, maybe also one without nail, just to show that it's working. So these classes are working 100% without any problems, because that's quite easy to distinguish from the other classes. So this is not a big task. The only thing is, like mentioned, the scratched, the bent ones and the okay ones, to distinguish those two. Yeah, now it's working. So
Yes, but we saw, but TMB, we tried to did some tests, and also we saw in the evaluation before that we do not reach the 100%, and sometimes we have misinterpretations to that they say it's bent, but it's an okay button. So bent and okay, this causes some problems. What are we doing to upload more photos, calculate the neutral network again, and yeah. This was the first, but I think the pretty interesting one, Matej will show you now from scratch, the application with the SD cards.
exactly, yeah. So for the SD card, we now got this classification learner on the device. So now we will just remove everything from the device. And then we are gonna load our Nova exactly on the device. So I'll click on install. Yes. So now we're just uploading the new app where we can also make anomaly detection. Yeah, we'll just overwrite the existing ones. And as you can see, it's quite fast. So I think it's about takes 1 minute maybe or something to change the app. And now we will be able to do as well anomaly detection and classification, although we will just only show here the anomaly part.
And what they show you here, the app manager, which is called App Manager, this is also a software free of charge, which you can use to make backups, to change apps on devices. As I mentioned some slides before, it's like a smartphone, yeah, and you can upload or download different apps based on the same device.
But maybe like this sample basic code reader, it's a sample app which we are offering on our GitLab and also on other platforms, which I can just easily install here just to add this to my existing project. So now if we refresh the site, we'll now have a different overlay overview of the site. Now we'll just make it quickly with the acquisition. This about 1000 should be right. So yeah, now we got this image. I already put here the SD card on top. Now we will just update our reference image. That will just quickly show you how to use here the anomaly detection. So for the first thing, we will need here an object locator to locate our SD card every time, because the idea is to just rotate the SD card and move it wherever we want. So this should also work on the device. So we can now maybe also test it to see, okay, if I make, okay, now it's not found. That's probably, yeah, because the rotation is not allowed. Scaling we will allow.
No.
Just some parameters. Maybe we'll also change the match score to 60%. We'll allow the angle in all directions. Now just to be on the sure side to see how good the object data will work before we use the anomaly detection tool. Okay. And now we can say, yeah, I want to use anomaly detection.
But they maybe show also that also all other machine vision tools are available, and you can
Exactly.
use
So
it in addition to deep learning. Yeah. So
So I could as well maybe use a pixel counter, a blob counter. So you will find here the typical tools which you will find in industrial vision. You will find as well here, just with the additional anomaly detection and deep learning classification, which is also here shown as trial. So you know, then, okay, if I run this, it will only work for 2 hours. Then I will need to reboot the device in order to continue with the generated app to see how it's working. So now we got here, you can see, so the anomaly detection is now below the object locator. So this means the object locator is the first step where we really search for the SD card, and later on, if we now put the anomaly detection window exactly on these pins we want to detect, cancel, can then maybe see, so maybe leave it like this. So if you now turn it, also the anomaly detection window should also be moved, as you can see. And this is done because we don't really know the position of the SD card, because it's not always in the same position. So we want to have the flexibility to say, okay, it's allowed to be anywhere in the image, the SD card, and we will still just search for these pins and check the anomaly on it. And like René showed in the slides before, so we have what you can see now in the image is the good part. Maybe I can also remove the outlay of this so we can maybe see it better. Yeah. So this is the good part, and we will now make multiple images of this part. So to do this, we will just go here and label the active image now as a good image. So we can see it here. In the meantime, yeah, René will just turn the SD card a little bit around, and every time he makes any change, make a new good image of that SD card. Yep. And the good thing about this is, so we won't really make now, I don't know, hundreds or thousands of images. We will just make maybe 10 images, and it still should be working quite well. So yeah. Maybe we can also move it maybe in some other directions. So I mean, at the end, the more images you make, the better this will work. The last one. Okay. So let's now say, okay, we are now done with our good images. The bad images we won't really consider, so we will just leave this blank and just train the network now with only the good images. I will take here 13 images, so we got 14. I will take 13 out of it, and the tool performance will now go to precise to detect also smaller defects. And as you can see now, the training is now done directly on the device. This will take now about maybe half a minute, one minute. And afterwards, I can use it at the moment the training is done. I can use this tool and see, okay, if I can detect my anomalies on the parts.
And as it was pointed out by Matej, everything he did now from scratch, we did directly here on our Inspector P611. We also, during the network is running, I also brought with you, maybe you see, that's the new Lector 611, our smallest sensor now on the market. And you also can do the same what Matej did now directly on this small sensor. Yeah, so this is on device because the device is able to store, I don't know, up to 100 images directly on the device. Yeah? So.
Yeah, so as you can see, training is now done, and we can now go to the evaluation part here. Nothing will, I mean, okay, this one is incorrect. Yeah, I could now label it as good. I will leave it maybe because here the problem is it's here a little bit too dark at the edge. We will just confirm this. We will say, okay, this one is okay. And you will now have here, maybe just one trigger, the anomaly score, the execution time of our network, because now we made a really precise one. it needs about half a second. And the anomaly score is shown here. So now 7.18, 2.2. So it was this. So you see that the anomaly score is really low. So 40 is now the threshold, and we are really far away from that. And now we will maybe start with the biggest one. So on this part, you will see we soldered the two pins together. It is now shown here on a blue greenish color where the defects are, or the anomalies regarding the golden part, or the reference part, and also the anomaly score is now 80 plus. So it's really clear that this is an anomaly, and this would now be recognized as not okay. Maybe another one.
Maybe with that one, this is also a wrong one. So here we scratched one of the connectors.
Exactly. So we scratched this one in the middle, and this one we just colored black. So it's also shown here, as you can see, also in a slight bluish way. So here we are also about 55. Anomaly score 67, always depending on the how you turn it. So to maybe have more stable results, maybe you should make more images, but this is complete enough to say, okay, if the part is okay, I got the anomaly score of maybe maximum 5. And now we are here on 70, and the average is not that big. I mean, we got
So
also
maybe we use now the SD card. It's really hard to see with human eyes. So we really did a really small scratch, a fine scratch, I would say. It's now
so now triggered it.
So
You can see now 40.57. So it's just this scratch, and now I could say, okay, it's 40.57, and I got my threshold on 40. I would say in this case I will go maybe down to 20 to be on the safe side. So if we make multiple images, it could occur that we now fall like now, maybe below 40, and in this case I would say this is okay. So we could also say, okay, if this is okay, I can just leave the score on about 40, 45. But if we want also to have this as bad part, I will go now down to 20. So this is now also classified as bad sample. We'll also turn it around a little bit. Now it's again on 40, 55.
It's running pretty robust, yeah.
And we made only maybe how much? Yeah, 40
Okay.
images with good only 14 good images, no bad image, and it's working very robust and fine with these settings. So I think this is really nice to show you what this anomaly detection and classification is capable of. And so are there maybe any questions so far?
Thanks a lot, Mate. This shows really nicely how easy is it to set up a deep learning device. Yeah, capture the images, label them, train the neural network, deploy it on the device. Yeah, and then we can start with the application solution. Yeah. Now we are 2 minutes close to 10, so we are pretty good in time. Did we forget something to mention here? But from my side, we presented what we want, or what was the plan. Yeah, and yeah, if there are no questions, so as mentioned by Isa, afterwards you have the possibility to get the presentation, also the recording. So if you have a project where you need support, or you want to have a classroom training and whatever, so please let us know. We would be happy to get in contact with you. And yeah, if there are no more questions, thanks a lot to the whole audience, and have a nice day. Ciao. What is